All right, gentlemen, last class we talked about how to solve a system of equations using a graph. Today we're going to learn a second of three methods, and today we're going to look how to solve it algebraically without using a graph. There are some benefits to this method. So first, before we talk about that second method, which is going to be substitution, the reason why we want another method is looking at this system of equations over here on the left. That would be tough to solve by graphing. You would have to do two steps to get both of those to be in slope-intercept form. You would get some decimals along the way, which would be pretty tough to show. And if you were to graph it, what if they ended up intersecting at some point which you weren't really sure like what that point was? It wasn't clear. At this point, we're not really sure what that is. So solving using a different method, an algebraic method, will allow us to get our x and y coordinate a little bit easier. When we're using the substitution method, there's just really a couple steps. The first step we're going to do is we're going to isolate a variable in one of the equations. So we're going to pick one variable, x or y, it doesn't matter, and we're going to pick one equation and isolate one variable. So there's always going to be four variables given. We're going to pick the easiest one to isolate. Once we isolate that variable, we're going to substitute it into the other equation, the equation we haven't used. That's going to give us an equation with only one variable. There will only be an x or a y in the problem. Then we're going to solve that to get our first value. So we're either going to get x equals a number or y equals a number. Once we have that, we have half of our answer. And we're going to take that number and plug it into either of the original equations to get our other value, whether it be x or y. That's going to give us our coordinate x comma y, which shows the intersection of 2 points. Our first problem here is y equals 2x plus 9 and y equals x minus 6. This would be a pretty easy one to graph, but I'm going to show you the substitution method. Step 1 says solve one equation for one variable. And this one's already set up because the first equation is already solved for y, and so is the second one. So what we're going to do is we're technically going to take our x minus 6, and since x minus 6 is the same thing as y, we're going to be able to substitute that into the other equation for y. So now I'm going to write this out as x minus 6 equals 2x plus 9. And like I said, this only has x's in it. So we can now solve this for x. So we want to get all our x's to one side and all our numbers to one side. So we get x equals negative 15. Now that's not our final answer because again, this answer is going to represent a ordered pair on our graph. So now we're going to take negative 15 and we're going to plug it into either x in the original equations. It does not matter which. So I think the second equation is easier, so I'm going to use that. So y equals negative 15 minus 6, and I get y equals negative 21. So I found my x value, I found my y value. My final answer is going to be the ordered pair negative 15, negative 21. That's where these two linear equations will intersect on a graph. So this has one solution at negative 15, negative 21. Our second equation here is basically the same as the last problem where both equations are already solved for y. So we're going to again take this x minus 7 and we're going to plug it in for y into the other equation. So we have 5x minus 15 equals x minus 7. And again, we're going to solve this for x. So I'm going to do two steps here just to save some space. So I get 4x equals 8. And I'm going to divide both sides by 4 to get that x equals 2. Again, that's not my final answer. I now have to take that and plug it in to one of the equations. I definitely think the second equation is easier, so that's where I'm going to plug it in. So I have y equals, instead of writing x, I'm substituting in a 2, and I get y equals negative 5. So my final answer is an ordered pair. X always comes first. 2 comma negative 5. Again, that means that these two linear functions intersect at one point. Next up, for our third problem here, again, step 1, solve one equation for one variable. It's already done for us. X is isolated in the first equation. So we're going to take 3y minus 25 and plug it in for x. So we have 5y plus. When we plug these in, this is the first one where they haven't been on opposite sides. I would always recommend using parentheses, because if we had a negative sign like right here, it would distribute to both sides. Here it's a positive, so it doesn't really matter, but just going forward, that might help. So the parentheses really will fall out. We can combine our like terms to get 8y, and I'm going to add 25 right now to both sides. So I get 8y equals 72. Divide both sides by 8, and I get y equals 9. Again, take that value and plug it into either of the equations. I'm going to pick the first one here. So x equals 3 times 9 minus 25. X equals 27 minus, let me go back. It should be a 25 up here. So I get x equals 27 minus 25, so x equals 2. Again, don't leave your answer like this. You got to write it as an ordered pair. So 2 comma 9 is our intersection point where these two equations or lines will intersect. All right, so this next problem is a little bit more tricky, just because our first step, which is isolate one variable, is not done for us. So looking at all of the variables, all 4 spots, you want to look for the easiest one to isolate, and it's always going to be easiest when the coefficient of the variable is 1. So we should all be focusing right here on this, on x in the first equation. That's the easiest variable to isolate. So we're going to take 8y plus x equals 10, and we're going to get x by itself. Now, you could solve for other variables, but that is definitely the easiest one to get by itself. So we get x equals negative 8y plus 10. We are then going to take that negative 8y plus 10, and we're going to plug it in for x into our other equation. So we have 5. We're going to substitute plus 10y equals negative 10. And now we're going to go ahead and solve. So 5 gets distributed, so we get negative 40y plus 50 plus 10y equals negative 10. Combine like terms, and we get negative 30y plus 50 equals negative 10. Subtract 50 from both sides. I'm going to swing this up to the top. So we get negative 30y equals negative 60. Divide both sides by negative 30. And we get y equals 2. Now, again, that's not our answer. We now have to take that 2 and plug it in for y in either of our original equations. So I definitely think it's easier to take that 2 and plug it into the first equation. So we have 8 times 2 plus x equals 10. 8 times 2 is 16. Subtract 16 from both sides. We get x equals negative 6. Final answer should be negative 6 comma 2. Again, that is the point where these two linear functions will intersect. Last one for today is, let's go ahead and get y by itself since it has a coefficient of 1. So I'm going to add 2x to both sides right here to get y equals 2x plus 2. I'm going to take my 2x plus 2 and substitute it in for y in that second equation. So 2x equals 3. Substitute in, write out the rest, distribute. Combine like terms, and I'm going to also move the 6x. So negative 4x equals 12. Divide by negative 4. I'm going to get x equals negative 3. Now I'm going to take negative 3 and plug it in for x in the original. I think it's easier to use, I guess it doesn't really matter. I'm going to use the first one. Y minus 2 times negative 3 equals 2. And solve for y. And final answer has to be an ordered pair, negative 3, negative 4. So this intersection is at negative 3, negative 4. Since they intersect, that means they have 1 point in common. That's it for today for this lesson. So we walked through 5 examples. You guys should have a pretty good idea on how this works. Remember, first step, isolate one variable. Second step, take that expression and plug it into the other equation. Remember, you can't plug it back into itself. That's not going to work. Solve that for the first variable. Then take that value and plug it into either of the 2 original equations to solve it for the second variable. And then lastly, write out the answer as an ordered pair.